Hello, my name is Daniel Houston, and this is my Lab 2 motion of a falling object. This lab observes the drop of an Among Us figurine dropped from rest. We will look at the forces of gravity and drag on this figurine in order to build a model of this fall. The observed data of the fall will be collected using Tracker, and the models will be built using Python. Now, there's a few assumptions that we'll be making today, and first of all, to increase the force of drag, the Among Us figurine will be using a parachute made from disposable mask. Additionally, the mass of the figurine with the mask parachute is about 0.025 kilograms. And now by using Newton's second law, we can approximate the velocity and the position with the given net forces. This is the video that we'll be using to take our observed data from this experiment. There are many net forces that we'll be looking at when looking at the object. First of being the force of gravity, which is the force of the Earth pulling the object down. Next is the drag force, which is like the air resistance to an object that moves in the opposite direction to the direction of motion. And then both of these come together to form the net force. Now, using these forces, we can enter these into Python and approximate the velocity and the position and the forces of the object using what we know. And then this is the model that the code generates whenever it is run. Now, looking at the given experimental position and the model position of both gravity and of drag, we can see a number of things. First off, when looking at just gravity alone, this tends to overpredict the position from the fallen object due to the lack of calculating the air resistance. But when we calculate the gravity and the drag, you can see the model lines up fairly nicely, although it does tend to underestimate the position. And this can be due to the camera quality or either faulty positioning in Tracker. So what does this mean? Well, during the current time interval, there is a point which the figurine reaches terminal velocity towards the end of the fall. This is shown in the velocity versus time graph by the velocity tapering off towards a constant value. And at this terminal velocity, the net forces of the gravity and drag will balance out to equal 0. Now, if the figurine was thrown instead of dropped from rest, the terminal velocity for both cases would still be the same. However, the object thrown would reach the terminal velocity either much faster or slower, depending on how much force the object was thrown with. Now, as you can see in the two graphs below, the one on the left, which has an initial velocity of 0, starts at rest, and then you can see reaches a terminal velocity of 3.3 meters per second, roughly around the 0.6 mark or the 0.7 mark. But in the velocity graph to the right, you can see the object is thrown at about -2 meters per second and also reaches a terminal velocity a little bit earlier. Thank you for listening to my presentation.